Good afternoon, friends, and welcome again to another discussion of the physics of class 12. So, this is another discussion of the physics of class 12. Today, we are dealing, this is class 12 chapter, we are dealing physics. So, today we will be discussing another topic, which is the reflection of light. So we will discuss reflection of light, and as you know that reflection of light is one of the important topics for any entrance exam, for board exam, for whatever it is. So you need to know a detailed knowledge about this chapter. Then only you will be able to understand and solve the questions. Okay. So as you all know that this is Parijat sir classes going on. This is Parijat sir classes, and I would request you to please like, share and subscribe. Like, share and subscribe so that it reaches out to the maximum number of students as much as possible, and they also will be getting the benefit. So here I have discussed the complete theory of this chapter 1, including the numericals. I have discussed here. So let us move ahead with the chapter and see what is there in it. First of all, you will be learning laws of reflection, and this is what you have already learned. I think this is what you have already seen from class 8. So I will not go into this in very much detail, just I will make you remind certain facts about this topic. So laws of reflection, as we all know, the laws of reflection says that if this is a plane mirror, then this is the normal, this is the incident ray, this is the reflected ray, this is the angle of incidence, this is the angle of reflection. So first law says that angle I is equal to angle R. This is the first law of reflection. Okay. Similarly, the second one discusses that if your ray of light, if the ray of light is traveling along the normal, that means if the ray of light is traveling like this, if the ray of light is traveling like this, it will return back like this. So if the angle of incidence is 0 degree, the angle of reflection will also be 0 degree for normal incidence. So the ray of light will retrace its path. Clear? Second, very important is total number of images. Number of images we are going to study here. Number of images. Now, let me first erase this. Okay. See, basically I will be discussing with you the facts which you have to just know. You don't have to know how it is coming. No derivations are important. So I will be just discussing these topics and putting it into your brain that what you have to know. That's it. You don't have to know in details how it is coming. Second, I want to show you, suppose if there are two mirrors, this is mirror 1 and mirror 2, this is mirror 1, this is mirror 2, and they are inclined at an angle theta, and suppose here is a point object, here is a point object. Okay. So how many images will this point object make with these two mirrors? If these two mirrors are inclined at an angle theta, how many images will I get? So there are two formulas. The basic formula here, n is the number of images. N is the number of images. Okay. The formula is 360 degree by theta minus 1. Now minus 1 or not minus 1 will depend upon whether this calculation is coming even or odd. For example, if this angle is 60 degree, then number of images will be 360 by 60, so which is coming 6. Okay, so we should have n as odd number of images, so then we will take -1. We always need, please remember, n should always be an odd number. N should always be an odd number. N should be an odd number. So if the angle is 60 degree, 360 by theta is coming 6, which is even. So we have to do -1. That means 5 images. And if the angle is between them is suppose coming, if the angle between them is suppose 75, so how much is it? 15 5s are 15, 2s are 30, 15 4s are 60, and this is coming 4.8. So now what we have to do, if this number is coming odd, if this number is coming odd, let me take another. If this number, suppose we take, let me show you with this example. Let me show you with this example. Suppose the angle between the two mirrors is 120 degree. So first I will do 360 by 120, which is coming 3. Now since this is already odd, you don't have to do -1. Your formula will be only 360 degree by theta. You don't, because this is already odd, so you don't have to do -1. Okay. If this comes even, then only you will take -1. Then only you will take -1. Otherwise not, because n should always be odd number. N should always be an odd number. Clear? Next, friends, see here. This is a concave mirror given here. This is a concave mirror given here. This is the principal axis x. X dash is the principal axis. Now this is the object. AB is the object. Please look here. AB is the object. First let me clear out the facts from here to make some space. Okay, so here as you can see that AB is the object shown here whose height is upward. So object is HO, which is upward, and that is why it is always positive. If the image, and this is the image, if the image is downward, its height will be shown as, it is HI, which will be shown as negative. So any line drawn above the principal axis is positive, and any line below the principal axis is negative. Similarly, any distances will be measured always from the pole. So if you are going again, suppose light is coming like this. This is the direction of light. As you can see, this is the direction of light. So if you are measuring against the direction, that distance is called as negative. This is the object distance. As you can see, this is the object distance, how far the object is. So since the object distance has to be measured from the pole, which is against the ray of light, so U is taken as negative. Similarly, this is the image. So if the image distance is measured, V, image distance is V. So if it is to be measured, then we are going against the ray of light. This is the ray of light. please take care of it. This is the ray of light. Let me show it to you. So my ray of light is coming like this. So in order to measure the image distance, I have to go in this direction. So V is negative. Okay. Similarly, so remember here, if you are going against the ray, it is negative. If you are going in the direction of the ray, it is positive. Okay, so in the direction of the ray is positive and against the ray will be negative. Above the principal axis is positive. Below the principal axis will be negative. Clear? So with this concept, let us move ahead. Relation between the focal length and radius of curvature. So this is the concave mirror, principal axis. This is the radius of curvature, which is 2f r, and this is the focal length f. So what is the relation between them? F is equal to r by 2. F is r by 2. For convex mirror, it is, remember, f is positive. For concave mirror, f is negative. Please keep these in mind. This is the mirror formula: 1 by v equal to 1 by u plus 1 equal to 1 by f. 1 by v plus 1 by u equal to 1 by f. F is the focal length. F is the focal length measured from this pole. This is the focal length. Okay. U is the object distance. And V is the image distance. Linear magnification, what is it? M, it is the height of the image to the height of the object, or it is the ratio of the image distance to the object distance. Clear? Now let us see here. An erect image, that means what? Erect image means the HI should be positive. Erect image is 3 times the size of the object. So image is 3 times the size of the object. So with a concave mirror of radius of curvature 36, that means, as I told you, the concave mirror focal length should be, the radius of curvature of the concave mirror is given, so its focal length should be r by 2, which is negative. Concave mirror focal length is negative, as it is mentioned here. Now the magnification is HI by HO, which is minus V by U. Now they are telling image height is 3 times that of the object, so I can write 3HO by HO. So minus V by U is coming 3, so V is coming minus 3U. V is coming minus 3U. So using the mirror formula, I can write 1 by F equal to 1 by V plus 1 by U. So putting the values of focal length and the value of V, so we get U is coming minus 12. That means the object was kept 12 centimeters in front of the mirror, concave mirror. Object was kept 12 centimeters in front of the concave mirror. Clear? Next, a candle is held 3 centimeter away. That means U is given. This is U given, which should always be negative, as I told you, which should always be negative. From a concave mirror of radius of curvature, this is R given, so focal length should be half of that, and it should be minus because concave mirror. Where is the image formed? They are asking V. So using the mirror formula, U is taken minus 3, F is taken minus 12. So calculating, we are getting V as 4. That means V is coming positive. That means if it is positive, then it is called, and it is behind, it is a virtual image. This will be called, if this is the mirror and if this is the object, the image will be behind the mirror. Okay, because V is coming positive, so it is, because the ray is coming like this, so U is negative. V is coming positive, so it has to be in the direction of the ray. V is coming positive in the direction of the ray. That is why it is virtual, erect and magnified. Virtual, erect and magnified. The image form will be virtual, erect and magnified. Clear? Next is, friends, what is the relation between the speed of the object and speed of the image? Now, if the object is, so see, here, suppose this is the mirror given. This is the object, which is U. Now, if the object is moving towards the mirror with a speed VO, the question is, how fast will the image also appear to the observer? If the object is moving at a speed of V0, how fast will the image appear to the observer? Image will move at what speed? If the object is moving at a speed of V0 towards the mirror, how fast will the image move towards the mirror? So this is the formula. Please note, you don't have any derivations of this, because you are studying for your entrance exam and you are studying for your board exam. So for board exams you don't have any of these derivations. You have only the formulas through which you will be asked the questions and the numericals. Okay, so this is the formula for the image, speed of the image, and same formula in terms of the focal length, in terms of the focal length. So please keep a note of this. Next is, in reflection of light, there is no change in the wavelength. Very important, very important that you don't have any change in the wavelength or frequency of the light. The wavelength and the frequency of the light will never change. Okay. Next is, if the length of the mirror is half, the length of the mirror is half of the length of the person to see him fully in the mirror. What does it mean? It means that if this is a person standing, his height is suppose 1 meter, then minimum how much length of the mirror do I need? I need a mirror of only 0.5 meter, which should be half of his length. So please note this, if the height of the person is 1 meter, that minimum how much length of the mirror should he need? He needs only half the length of his height. The mirror should be half the length of his size. Next, a square wire of side 3 centimeter, that means the sum is about like this, that if this is a mirror, the sum is like this. If this is the mirror, this is the principal axis, here is a square wire of side 3 centimeter given, place 25 centimeter from the mirror, which is U. So this is U given, which is negative. Okay, focal length is a concave mirror, so focal length should be negative. Focal length should be negative. What is the area enclosed by the image of the wire? First of all, I want to find out where is the image located. Okay, so using the formula 1 by v equal to plus 1 by u equal to 1 by f. F is negative, u is negative. Find out the v is coming negative. That means v is forming, what's here, it is coming minus 16 point something, 16.66 centimeters, and the wire was placed at 25 centimeters. That means the image of the square will be somewhat like this, okay, which is 16.66 centimeter from the wire. Because it's negative, so it is formed in front of the mirror. Now magnification I want to know. Magnification, height of the image by the height of the object. That means what will be the length of the sides now? This length is 3 centimeter, 3 centimeter, 3 centimeter, 3 centimeter. But what is the size of this? So height of the image by height of the object is minus v by u. So let us put height of the object was 3. So let us put v is coming negative, u is coming negative. So this has come minus 2 by 3. So hi has come minus 2. That means each side is 2 centimeter. That means the area will be, because it is a square, to square of the side 4 centimeter square. This will be 4 centimeter square area. Clear? Let's move on to the next sum. You notice a jogger. A jogger is approaching towards you in a rear view mirror. The mirror's radius of curvature is given to us as 2 meters. So its focal length will be, please watch, rear view mirror are always convex mirror. Rear view mirror are always convex mirror. The mirror which is put in your car for your view, that is a convex mirror. So radius of curvature is this, and so focal length should be r by 2, which should be plus, because focal length of a convex mirror is positive. The jogger is running to you at a speed of this. That means this is v0 given. How fast? So v, when the jogger is 39 meter, so u given, this is u given, u is minus 39 meter. V, speed of the jogger is given 5 meter per second. They are asking what is the speed of the image of the jogger. So first of all, we know that this is the formula for finding the speed of the image. So I need vu. So using this formula, focal length is 1 meter, 39 meter, okay, we get v as plus 39 by 40 meter. So now you putting it in this formula, the values of u and v, u is negative as you can see, but v is coming positive. So we get that the speed of the image jogger will appear to me is coming towards me at a speed of minus 1 by 320 meter per second. Clear? Let us see the next one. Size of an object P is 4 times the size of an object Q. P's size is 4 times the size of an object Q. Okay. It is required that the size of the images of P and Q placed one after the other at a certain distance away from a concave mirror. It is a concave mirror, so focal length will be negative. Radius of curvature given, so focal length we can easily find out. This is the focal length is half of the radius of curvature and minus 10. Why? Because it is a concave mirror. Concave mirror. They have given that the size of the image of P and Q should be equal. So if the object is kept at 50 centimeter away, where should the Q be kept from the mirror? Okay, so they are telling us one thing, that is, there is an object P which is 4 times the size of an object of Q. P is 4 times the size of Q. Clear? And P is kept 50 centimeter away from the mirror. So let us find out for P. U is minus 50, so V is coming minus 25 by 2. This is the image of P. This is the image distance of P. Image distance of P. Now, what is the magnification of P? It's minus V by U. So V is coming minus, U is always minus. It is coming minus 1 by 4. Now, HI by HO is the magnification, which is minus 1 by 4. Now here they are telling that the height of the image is 4 times the height of the object, of an object Q. Okay, so as you can see from here, I am getting HI is minus 1 by 4 of HO, which is comparable to the, I am finding out for the P, height of the image of P is coming minus 1 by 4 height of the object of P. For P, it is only for P, ki whatever is the height of P, its image is coming minus 1 by 4. So let us see. They are telling that height of the image and the height of the image of P and height of the image of Q should be same. Here they have given that they should be equal. The size of the images, as you can see, I am marking it here, friends, I am marking it here. Size of the image of P and Q should be same. So if this is the size of the image of P, the size of the image of Q should be same, which should be this. Okay, so HIQ is minus 1 by 4. Now they already told that P is 4 times that of the Q. So here it is 4HO. So calculating it, we are getting the magnification is coming HI by A, height of the image of Q by height of the object of Q is coming minus 1. Because they are same, because the height of the image and the height of the object is same, we know this can only happen if you place the object at the center of curvature. Please remember that you can only get the height of the image and the height of the object same only when it is placed at the center of curvature. Please note this point. The image height and the object height could be same only when it is placed at the center of curvature. So what is the center of curvature? Center of curvature distance is 20. Center of curvature means it's the radius of curvature, which is 20 given. So the Q should be placed at 20 centimeter in front of the mirror. Clear? So friends, this was the first part. This was the first part of the reflection, and since we have maximum things discussed already in the previous classes, as you already know that reflection is a chapter which you have already done. So I am covering it up, only the portions which you require it for your exams, that's it, because maximum questions will come from the second part of the optics. That is why I have given you an overall view of the first chapter, only the things which you require. You don't require so many things, you require only the basic things. Clear? We will be discussing optics part 2 very soon, and in that we will be discussing the complete optics, which is the most important part of the optics chapter. So till we meet for the second part, it's goodbye and thank you from my side. Please keep watching Parijat sir classes.